Welcome in the video number 21 of this ongoing video series, the D and F block elements. Now before we proceed further, there is another joke, this time a biology joke, not a chemistry joke. Okay, do you think do you know what really make me smile? What really makes me smile? Think, think. Okay, I'll give you the answer. Simple, facial muscles. uh, you never to be always a scientist. You needn't to be always a scientist to get the answer. A simple innocent childlike thinking can make the answer. So simple facial muscles makes me smile. Okay, now we are discussing about the formation of alloy. So the transition elements, the transition elements the transition elements have maximum tendency the transition element have maximum tendency to form alloy. Okay, apart from if we see the elements in the S block, elements in the P block, only this transition element have that maximum number of alloys. Okay, so let's find out why it is so. The reactivity, the reason being that the reactivity of transition elements the reactivity of transition elements is always very less. In comparison to those of S block elements, S block metals, and their sizes are almost similar. Almost similar, as we have seen in our previous discussion, in your previous video. Due to some factors like length night contraction, night contraction, their sizes are almost similar. Okay, due to this a transition metal atom due to this a transition metal atom due to this a transition metal atom in the lattice in the lattice can be easily replaced by can be easily replaced by other another transition metal atom. Lattice means it's a three-dimensional network of ions, cations, or the 3D structure where different constituent particles are fixed. So, due to this, a transition metal atom in the lattice can be easily replaced by another transition metal atom, and hence they have maximum tendency to form alloys. Okay, now here further we can say in the alloys in the alloys uh, the ratio of the component in the alloys the ratio of the components the ratio of the components uh, is fixed. Now here one more thing I would like to say that in the composition is fixed. Apart from metal atoms, there can be some non-metal as well. One of that is carbon. Even carbon is the constituents of various metals, especially the steel. So we'll see some example later on. And at last, I can say there these alloys these are these alloys are extremely hard and have high melting points. That's why in making machinery, utensil, etc., alloys are preferred rather than the simple metals. So these are the you can say some properties of alloys formation and their region. Now here we'll see some examples there. So some important alloys are there. Okay, uh, some of them you are familiar with. Bronze, that is being used for medals and making utensils. Brass, here see copper. Tin, in that much ratio 75 to 90%, and tin 10 to 25% copper. And zinc, copper being 60 to 80% and zinc being 20 to 40%, that makes the brass. Then gunmetal, German silver, bale metal, for of which the bales are being made, copper and tin. Nichrome wire, nickel, chromium, and iron, that is being used in heaters. In 10th class I think you have studied that. And similarly some other alnico. Then there are some types of steels, various types of steels. Here you can say solder, that is lead and tin. So these are the various example of alloys. Now here are the different forms of iron where how much carbon is being used in wrought iron 0.1 to 0.25%, and so on pig iron maximum amount of carbon.